page 54, our TEK is 2H. This is our last lesson before we start getting ready for your test. It'll be next week. Okay, so writing linear inequalities. This right here is going to be like, we've already done this year. This is just kind of a recap of what we've done. All right, so they just want us to write a single inequality here that we would like put on the number line. Does that make sense? And I'm going to use X every time because you know I prefer X. So it says Sue has a maximum of $120 in her bank account. So if I use X and I have $120 and it says she has a maximum, what inequality would go in there? X is what in relationship to 120? Do what? Less than or equal to, because she can have less than, because the max is 120, right? So I can have less than 120, or I can have exactly 120, but I can't have more than that. Are we okay there? All right, the next one, Chin's account balance is above $50. Bianca, if it's above $50, how am I gonna write that? Say again? Yep, X is greater than $50. Are we okay there? All right, the next one, Angelica has no more than 230 in her account. So if I can have no more than 230, what is that gonna look like? Yep, less than or equal to, good. All right, the next one, Kadeem has at least $72 in his account. Maddie Rogers, if I have at least $72, what's that gonna look like?
X is greater than or equal to?
Greater than or equal to. She has at least 72. So 72 is the least amount. Anything more than that is good. Are we okay there? All right. Bo's account has no less than 15. Now, if I have no less than 15, what does that mean I must have? Greater than or equal to. Everybody okay there? I can have 15, I can have more, but I can't have less than. Everybody good there?
Yes, sir.
Okay. So that's that part. It's just kind of reminding us which inequality to write based on what those keywords say. All right, so we can also do the same thing when we're writing them in linear. So when we did linear equations, we're going to have, instead of just having an X, we're going to have an X and a Y. Everybody okay there? All right, so this one down here, it says Kel and Eric are throwing darts at a target. The darts that land in the white regions earn 2 points, and darts that land in the gray region earn 4 points. So white are 2 and gray is 4. So 2 and gray is 4. I'm just kind of writing that because I can see it since I have a little dartboard there. Okay. All right. Then in part A, it says if Kale scored no more than 40 points, okay, write an inequality to represent the possible combination of X, the number of darts that were white. So white is X. So I'm gonna put that there, which usually the first one they give you is X. All right, and then Y, the number in the gray. So if they don't tell you which one is X and Y, a lot of times they do, but sometimes they don't. If they don't tell you whichever one is listed first, it's going to be X. Everybody okay there?
Yes, sir.
All right. So if Kel scored no more than 40 points, what is that going to look like?
Greater than or equal to? Or less than or equal to?
Less than or equal to, so something is less than or equal to 40, right? Okay, so what is less than or equal to 40? What information do I know about them? Because he's playing darts, so what do I know when I throw my stuff at the dartboard? What do I know?
You get 2 points when you hit the white.
Okay, 2 points for what?
The white, when you hit the white.
Okay, which is represented by what?
X.
Okay, so how am I gonna write that?
2X.
2X, okay.
Plus 4Y.
Okay, plus 4Y. Everybody good there? Everybody all right with that one? All right, the next one. If Eric scored at least 52 points, write an inequality that would represent his. So at least 52. Alright, so what do I know about this one?
Something's gonna be greater than or equal to 52.
Okay, something's gonna be greater than or equal to 52. So what is my something over there?
2x plus 4y.
2x plus 4y. Okay, so that didn't change, it's just the points changed and what was on the other side changed, right? But white is still 2 points and gray is still 4 points, right? That didn't change. Alright, the next part said, would it be possible for Kale, so we're talking about this guy, to have had 15 darts land in the white and 3 darts land in the gray? So how can I check that to see? I'm gonna plug it in there, alright? So what is that gonna look like?
2 times 15
Okay,
plus 4 times 3 is less than or equal to 40.
so they're equal to 40. Okay, so 2 times 15 is 30, and 4 times 3 is 12, less than or equal to 40. 30 plus 12 is, so 42 less than or equal to 40. Is that true?
No.
No, it is not true, so the answer to that is no. And when it says explain, your work is your explanation. 42 is not less than 40. It's not equal to, nor is it less, so it doesn't work. We okay there? Alright, number 2, Leon has a jar full of dimes and quarters. Okay, the total value of the coins in the jar is $30. Alright, they want us to write an inequality to represent possible combinations of X, the number of quarters, so I'm going to put an X up here for my quarters, and Y, the number of dimes, which, right, Y, the number of dimes. So they wrote them in a different order. I typically, whichever one is first, I call X, but if they tell you specifically, make sure you connect what they're saying is X and Y. Okay, so what do you know about a quarter?
It's worth 25 cents.
It's worth 25 cents. How do I write that?
25x.
Huh?
25x.
Alright, 25x. Say that again? 0.25x. I have to write it with its actual value. Are we okay there? This sometimes even trips up my algebra 2 and 2 kids because if they want to write it as 20, I can't write it as 25 because its value is not 25. Its value is 0.25. Are we okay there? Alright, so I have 0.25x. Okay. And then I have some dimes. How am I writing that? Okay. 0.10y. Okay, and then it says that, what am I going to do with these things? Like I gotta have an operation in there. I gotta add them. And putting them, if I'm putting them in the jar, then I'm adding money to the jar every time I put them in there, right? So I'm gonna add them. Alright. And then it says he has at least $30. So how am I gonna write that?
Less than or equal to 30.
What'd you say? He has at least 30. Can he have more than 30?
Yes.
At the least he has 30. So how am I writing that?
Greater than or equal to.
Greater than or equal to. So if you get on these like here and that kind of trips you up, so write it like this and don't put a sign in there and leave the sign out for a minute and then go back and read what it says, because if it says at least 30, then you need to sit there and say, okay, can he have 30? If the answer to that question is yes, you have an equal to line. And then if it's and then when you look at that you say, okay, can it be more than 30? Well, at least 30 means yes, I can have more. Or if the answer to that is no, then you would make it less than. Does that make sense? So if you have a little bit of trouble deciding, write this part and write this part and then wait and then go back and decide your inequality after you read, okay, can this be more than or can it be less than? Does that make sense? To help you a little bit on that. Okay, so then it says, is it possible for Leon to have 100 quarters and 50 dimes? So how am I going to know if that's possible?
Plug it in.
I'm going to plug it in. Okay, so what's that going to look like?
0.25 times 100 plus 0.10 times 50 is greater than or equal to 30.
Okay, so when I do 0.25 times 100, that's 25. And when I do 0.10 times 50, that gives me
5.
5, supposed to be greater than or equal to 30. So 25 plus 5 is
30.
30, greater than or equal to 30. Is that a true statement?
Yes.
Yes, so my answer to that is yes, he can have that. That would give me exactly $30, right? Okay. The next one, if Leon has a total of 90 quarters in the jar, they want us to write an inequality that would tell me why, the possible number of dimes. Okay, so what do they want me to do here? Bless you.
Thank you.
What do they want me to do here?
I'm just writing inequality.
Okay, well I already have an inequality for my situation. So this is why these trip you up sometimes. What piece of information did they tell me?
That the total quarters in the jar is 90.
They told me I have 90 quarters. What do I do with that 90 quarters? I'm plugging it in for X. I'm still using my same inequality. None of the other stuff has changed. Does that make sense? It's the way they word this that kind of messes you up. Okay, so I have 0.25 times 90 plus 0.10y greater than or equal to 30. Because y'all understand, like none of the other information that I was already given has changed at all. Whereas like up here, where was it? Yeah. Here, the same thing happened. I still had 2x plus 4y. They each had a different score, right? Okay. Here, they didn't change. The value of a quarter didn't change. The value of a dime didn't change. I don't know how many I have of this, but they told me how many of this. So that's the only thing that changed was they told me to use 90 there. We okay there? Alright, so what do we get right here?
22.5.
Okay, so I got 22.5 plus 10y greater than or equal to 30. Alright, now what do I do? Because I want an inequality to represent y, which means I want y. I'm going to move my, well I don't have x anymore.
Just move 22.5.
I'm going to subtract my 22.5, which I guess in reality is kind of my x. I just don't have the actual variable anymore. Okay, so now I have 10y greater than or equal to 30 minus 22.5 is 7.5, yeah?
Yes, ma'am.
Okay, now what do I do?
Divide everything by 10.
Divide everything by 10.
Or wouldn't it be 0.10?
Yes, 0.10, thank you. You are absolutely correct. Okay, so then y would be greater than or equal to, and I'm never leaving a decimal in there like that, so what does that get me when I divide that out?
0.75. So it would be 3 over 4.
7.5 divided by 0.10.
Oh.
75, okay. So the question wanted me to find out an inequality represent y, which is the number of dimes. Is that a logical number of dimes?
Yes.
Okay, so if I got a decimal here, would it be logical to get part of a dime?
No.
No, so you remember, go back and check your question and make sure that the number that you got is logical for what they're asking you, okay? Because when I'm asking about the quantity of a whole thing, I gotta have a whole number. Does that make sense? Okay, everybody good on that? Alright, so go to the back. And it says, the table lists the price per pound of different berries at a farmer's market. So I've got strawberries are $2.50 a pound, blackberries are $4 a pound. Jamie wants to spend a maximum of $20 on the berries. Write an inequality represent the possible combination of X pounds of strawberries, so I'm gonna put an X up there, and Y pounds of blackberries, which is how I would have done it anyway because strawberries was listed first. Alright, so it says that she wants to spend a maximum of $20. So how am I gonna write this inequality? Okay, so what am I putting on the left side?
2.5x.
Okay, 2.5x, okay,
Plus 4y.
plus 4y, and I got 20 over here. So what is my inequality that goes in there? I think y'all said it a while ago, I just wasn't really sure. Less than or equal to. It has to be less than or equal to because 20 is the most that I can possibly have. So 20 should be more than that, or exactly that. Does that make sense? Cause if they bring it up and it's $21.50, I can't do that, cause I only got $20, does that make sense? Okay. B, Jamie has 2 pounds of strawberries in her basket. Write an inequality to represent the possible pounds of blackberries she can purchase. Alright, what am I doing here? I'm plugging in 2 pounds for X. So I've got 2.5 times 2 plus 4Y less than or equal to 20. Alright, 2.5 times 2 is 5 plus 4Y less than or equal to 20. Now, subtract my 5. I've got 4Y less than or equal to 15. Now what would I do?
Divide 4.
Divide out my 4. And since we're getting this in pounds, we'll go ahead and we can use the decimal here. So I get Y is less than or equal to 3.75 pounds. That particular problem, like we're not gonna write 15 over 4 pounds. We'll go ahead and write it as 3.75. We okay there? Alright. Okay, number 4, a local restaurant has a drive-through and a dine-in option. In the last hour, the restaurant served no more than 70 customers. Okay, so then this says write an inequality to represent the possible combinations of X, dine-in, and Y drive-through, and then they want us to do a graph. Okay, I'm gonna go ahead and kind of deal with this. X is what? What did they tell us? Dine-in, and then that means Y is drive-through. I'll go ahead and label those, that way I know what X is and what Y is. Okay, so they're gonna serve no more than 70 customers. I have some of this, and some of this, so how am I writing that? Dine-in is represented by what?
X.
Drive-through is represented by?
Y.
So I got some of each of those, so how am I writing that? Dine-in is represented by what? X. What does X mean? I mean, I know it's dine-in.
The number of
It's
people
how
that
many,
dine in?
right? Do I know how many?
At least 70, or no more than 70.
I'm talking about X specifically. Do I know how many?
No.
No, that's why I'm using X, right? Okay, here. My drive-through is represented by what?
How many people go
How
to
many
the
or
drive-thru?
Y? Do I know how many?
No.
No, that's why I'm using Y. So what does that part look like?
X plus Y?
X plus Y. I don't know anything more than that. They didn't, there's not a value assigned to them because it's just a quantity. Are we okay there?
Yes, ma'am.
It's not like when we have like movie tickets and they're $2 and $4 or something like that. There is no other information, so it's just a quantity of X and a quantity of Y. It's a person for a person, right? They either did this or they did this. We good there? Alright, now I can go deal with this part. They served no more than 70. How am I writing now?
Less than or equal to 70.
Less than or equal to 70. Alright, now they want me to put that on the graph. Can I put it on the graph in this format?
No.
No. Okay, so how do I do that? What do I have to do?
Subtract your X.
And subtract my X off. So I end up with Y is less than or equal to negative X plus 70.
Yes.
Can I put that on the graph now?
Yes.
Okay, what do I graph first?
Y-intercept.
Okay, it is at,
70.
okay, so that goes there. Alright, is my interval the same for X and Y?
Yes.
What is the interval?
10.
10. And since it's it's 10 for 10, then 10 over 10 is the same thing as 1 and 1, so I can count by ones, right? And it's a negative slope, so I'm basically right here, all the way down. Now, it is an inequality. Do I have a solid or a dashed line? I have a solid line. So I'm going to draw that, and because this is a real world problem, these are really common. We only get that first quadrant, because remember, my X and my Y represent people, and I don't have negative people. They might have negative thoughts, but we don't have negative people. So we're not going to have anything in the negative area. That's why they only gave us the positive for the coordinate plane. Are we okay there? All right. So what does my line represent? Anybody have an idea what my line represents?
The slope.
It's not the slope.
It's like the number of people leaving.
Okay, the line represents my number of people, my 70 customers. Because this one is specifically, it says 70, right? So it represents my 70 customers. Are we all right with that? Yes?
Yes, ma'am.
Okay, now where would I shade this graph? Below. So my shading is all down in here. Are we okay there? Okay, now if I come over here, it says, explain how you could use the graph to determine the number of drive-through customers that there were if the restaurant served 20 dine-in customers. Alright, so if I serve 20 dine-in, I'm right here, right? Is this the only spot that is a solution when X is 20? No. Basically, all of this would be if I had 20, right? Yes? Okay. So the maximum, if I had 20, what's the maximum amount of drive-through?
50.
50. Can I have less than that?
Yes.
Okay, so it would be 50 or less, right? Okay, one more thing. All right, here, 50 represents my max. It is on the line, and it's okay. Are we all right there?
Yes, ma'am.
Less than that is the shaded part, and all of those are okay, right?
Yes, ma'am.
All right, now here's the deal with this. If I'm right here, this point represents what?
How many customers?
70 dine-in. So if I served 70 dine-in, how many drive-through would I be serving?
0.
0. If I served right here, this is 70 drive-through, how many dine-in would I be serving?
0.
Also 0. Does that make sense?
Yes, ma'am.
Okay, and so all of this on the line is 70, but all this is less than 70, and I can serve anywhere in that shaded area or on that line. Are we okay?
Yes, ma'am.
All right, we'll finish this up tomorrow.